Assalamualaikum warahmatullahi wabarakatuh. Good morning, Excellencies, distinguished guests, participants, ladies and gentlemen. We are delighted to welcome you to International Conference of Informatics, Mechanical, Industrial and Chemical Engineering, ICIMICE 2023, at the Seminar Nasional Sains dan Teknologi 13 Snst.
Selamat pagi dan selamat datang dalam acara International Conference on Informatics, Mechanical, Industrial and Chemical Engineering ICIMICE 2023 dan Seminar Nasional Sains dan Teknologi Snst ke-13.
Direktur Universitas Wahid Hasyim, Profesor Dr. Muzakir Ali MA, the Dean of the Faculty of Engineering, Dr. Sri Mulyo Bondan Respati, STMT, Professor Ito Kozo from Department of Applied Chemistry, University of Tokyo, Mr. Willy Bukletin, PhD, from Cavite State University, Philippines, Mr. Ferry G, PhD, from Edith Cowan University, Australia, and also presenters and participants.
Yang terhormat Rektor Universitas Wahid Hasyim, Profesor Dr. Muzakir Ali MA. Yang kami hormati Dekan Fakultas Teknik, Dr. Sri Mulyo Bondan Respati, STMT. Yang kami hormati Profesor Ito Koyo dari Departemen Kimia Terapan Universitas Tokyo. Yang kami hormati Bapak Willy Buklatin, PhD dari Cavite State University, Filipina. Yang kami hormati Bapak Ferry G, PhD dari Edith Cowan University, Australia. Yang kami hormati para Wakil Rektor Universitas Wahid Hasyim. Yang kami hormati para Dekan Universitas Wahid Hasyim. Dan yang saya banggakan pembicara dan peserta.
ICIMICE 2023 and 13 Snst is annual conference proudly organized by the Faculty of Engineering, Universitas Wahid Hasyim, with co-host Universitas Trunojoyo. The ICIMICE 2023 and 13 Snst bring the theme The Impact of Industrial Revolution 4.0, Society 5.0, Digital Transformation. This theme show who we are decided to using research result on all aspects of engineering, science, and technology to tackle important issues in these areas. During today, we will have the good fortune to hear from eminent speakers who are each pioneer in their respective fields. Our proactive involvement in fostering change will be inspired by their insight. This event was held online via Zoom and YouTube.
ICIMICE 2023 dan NSTC ke-13 merupakan konferensi tahunan yang diselenggarakan oleh Fakultas Teknik Universitas Wahid Hasyim dengan co-host Universitas Trunojoyo. ICIMICE 2023 dan SNST ke-13 mengusung tema Dampak Revolusi Industri 4.0 terhadap Transformasi Digital Society 5.0. Tema ini menunjukkan bagaimana kita mendedikasikan hasil penelitian pada semua aspek teknik, sains, dan teknologi untuk mengatasi isu-isu penting di bidang ini. Pada hari ini, kita beruntung bisa mendengarkan pembicara-pembicara terkemuka yang merupakan pionir di bidangnya masing-masing. Acara ini dilaksanakan secara online melalui Zoom dan YouTube.
Excellencies, distinguished guests, participants, ladies and gentlemen, now we will listen to recitation of the Quran by Malik Fajar Ibrahim, student of Informatics Program Studi, Universitas Wahid Hasyim.
Bapak Ibu yang kami hormati, acara dilanjutkan dengan pembacaan ayat suci Al-Quran oleh Malik Fajar Ibrahim, mahasiswa dari Program Studi Teknik Informatika Universitas Wahid Hasyim.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم يا أيها الناس قد جاءتكم موعظة من ربكم وشفاء لما في الصدور وشفاء لما في الصدور وهدى ورحمة للمؤمنين وشفاء لما في الصدور وهدى ورحمة للمؤمنين وشفاء لما في الصدور وهدى ورحمة للمؤمنين بسم الله الرحمن الرحيم وننزل من القرآن ما هو شفاء ورحمة للمؤمنين ولا يزيد الظالمين إلا خسارا وإذا أنعمنا على الإنسان أعرض ونأى بجانبه وإذا مسه الشر كان يئوسا قل كل يعمل على شاكلته فربكم أعلم بمن هو أهدى سبيلا بسم الله الرحمن الرحيم ادع إلى سبيل ربك بالحكمة والموعظة الحسنة وجادلهم بالتي هي أحسن إن ربك هو أعلم بمن ضل عن سبيله وهو أعلم بالمهتدين وهو أعلم بالمهتدين صدق الله العظيم والسلام عليكم ورحمة الله وبركاته.
Excellencies, distinguished guests, participants, ladies and gentlemen, now we will sing the Indonesian anthem, Indonesia Raya.
Hadirin dimohon berdiri, menyanyikan bersama lagu kebangsaan Indonesia Raya.
Audience, have a seat please.
Hadirin dipersilakan duduk kembali.
Excellencies, distinguished guests, participants, ladies and gentlemen, now we will listen to the opening speech delivered by the Dean of Faculty of Engineering. Ladies and gentlemen, please welcome Dr. Sri Mulyo Bondan Respati, STMT.
Bapak Ibu yang kami hormati, acara dilanjutkan dengan sambutan Dekan Fakultas Teknik Universitas Hasyim. Kepada yang kami hormati, Bapak Dr. Sri Mulyo Bondan Respati, STMT, disilakan.
Mechanical, Industrial, and Chemical Engineering, ICMS 2023 and Seminar Nasional Sains and Teknologi 13 Snst. Organized by the Faculty of Engineering at Hasyim University with the theme The Impact of Industrial 4.0 to Society 5.0 Digital Transformation. This international conference is part of a series of conference and workshop activities provided by the Faculty of Engineering at Hasyim University and the co-host Trunojoyo University. ICIMICE 2023 and 13 Snst bring out ideas and research in the field informatics, mechanical, industrial, and chemical engineering toward sustainable development. This conference promotes a new approach and information and the aforementioned fields. All of this support of creating sustainable energy and technology without depleting national resources. The objective is ICIMICE 2023 and 13 SSTR, creating an international forum for researchers, students, industries, and government to communicate their research results on the fundamental and application of informatics, mechanical, industrial, and chemical engineering. Sharing and exchanging ideas, thought, and discussion on all aspects of informatics, mechanical, industrial, and chemical engineering. Facilitating information and network among participants to exchange the quality and benefit of research and development. Furthermore, the conference also constitutes a great opportunity for escalating cooperation among institutions term various academic necessities. I would like to thank the keynote speaker for allowing us a chance to experience value sharing. It's essential to get expert in the field of science and technology to improve the quality of postgraduate education. In ICIMICE 2023, there are 90 papers submission, and only 74 papers are accepted for presentation, which is around 92% acceptance rate. In such an SIT, there are 90 paper submission, and only 61 papers are accepted for presentation, which is around 76.7% acceptance rate. The accepted paper will be present in regular parallel or session via online, and after the paper has been revised and accepted, will publish in the AIP conference proceeding with an estimate on 8 to 12 months. This diversity order come from 5 different countries of the Indonesia. They are from Philippines, Japan, Australia, Thailand, and Malaysia. We would like to thank for all keynote speaker, reviewers, author, Rumah Publikasi Indonesia, RPI, and committee for their effort, guardian, contribution, and valuable support. We would like to also extend your gratitude to Hasyim University, Biodam, Material Laboratory, Desain Laboratory, Majalah Ilmiah Momentum, Juna Inteka, and Jin RPL for support by DS1. Wal muwafiq ila muwaffiq. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Sri Mulyo Bodan Respati, STMT.
Disampaikan terima kasih.
Excellencies, distinguished guests, participants, ladies and gentlemen. Now, we will listen to the opening speech delivered by the Rector Universitas Wahid Hasyim. And afterward, we would like to request the Rector to officially open International Conference on Informatics, Mechanical, Industrial, and Chemical Engineering, ICIMICE 2023, and Seminar Nasional Sains dan Teknologi 13 Snst. Ladies and gentlemen, please welcome Professor Dr. Muzakir Ali MA.
Hadirin yang kami hormati, acara dilanjutkan sambutan sekaligus pembukaan secara resmi International Conference on Informatics, Mechanical, Industrial, and Chemical Engineering (ICIMICE 2023) dan Seminar Nasional Sains dan Teknologi (SNST) ke-13 kepada yang terhormat Bapak Profesor Dr. Muzakir Ali MA. Disilahkan.
Assalamualaikum warahmatullahi wabarakatuh. Bismillah, alhamdulillah, salatu wassalamu ala rasulillah Sayyidina Muhammadin wa ala alihi wa ashabihi wa ala ba'du. Good morning, peace be upon you. Excellencies, Vice Rectors, Excellencies, Dean of Engineering Faculty of Hasyim University, Excellencies, Speakers, Mr. Willy Buchlatin, PhD from Sheffield State University, Philippines, Mr. Professor Ito Kohyo, Tokyo University from Japan, Mr. Feriji, PhD from Edith Cowan University, Australia, and Trunojoyo University as co-host, distinguished guests, participants, ladies and gentlemen. First of all, in this beautiful moment, I would like to express my deepest thanks to you all in this meeting. Thank you and welcome to Hasyim University. I would like briefly introduce our university. That Hasyim University is a leading Islamic university in Central Java, Indonesia, under patronage of Nahdlatul Ulama, promoting peace, moderate, and tolerance. So our vision is to become an excellent university in transforming and pioneering discoveries of science, technology, and art based on Islamic values of Ahlussunnah wal Jamaah, namely moderate, tolerant, justice, and balance. We believe that these values are very important to building the world civilization, which is full of peace and harmony in general, and particular for creating the better generation who has good character and excellent intellectual capacity. Secondly, it's my great pleasure to welcome you all to the International Conference on Informatics, Mechanical, Industrial, and Chemical Engineering 2023 and 30th SNST, Engineering Faculty of Hasyim University. This conference provides an unique opportunity for leading academic scientists, researchers, and industrial practitioners to exchange new ideas, share their latest findings, and discuss the challenges and opportunities in their respective fields. I would like to thank the organizers for their hard work and dedication in putting together this event, and I hope that you will find it informative, engaging, and rewarding. Ladies and gentlemen, the theme of this conference, Informatics, Mechanical, Industrial, and Chemical Engineering, reflects the diversity and breadth of the engineering field. These four areas are interconnected and interdependent, and they offer exciting opportunities for collaboration and innovation. Informatics deal with the processing, storage, and retrieval of information, and it has revolutionized many aspects of our lives, from communication and entertainment to healthcare and education. Mechanical engineering focus on the design, analysis, and manufacturing of mechanical systems such as machines, engines, structures. Industrial engineering deal with the optimization of complex systems and processes such as supply chain, logistic, and production lines. Chemical engineering deal with the design and operation of chemical processes and plants such as refineries, petrochemical, and pharmaceutical. Together, these areas of engineering offer a rich and diverse landscape for research, development, and innovation. In closing, we would like to thank you all for your participation in this conference. We hope that you will find it informative, engaging, and rewarding, and that it will inspire you to continue your work in the field of engineering. Let us embrace the challenges and opportunities that lie ahead, and let us work together to create a better future for all. So, I hereby open this event officially with Basmalah together. Bismillahirrahmanirrahim. Happy conference. Thank you so much for your attention. Wallahul muwaffiq ila aqwamit thoriq. Peace be upon you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Profesor Dr. Haji Muzakir Ali MA.
Disampaikan terima kasih.
Excellencies, distinguished guests, participants, ladies and gentlemen, we will now pause for a moment of reflection. Mr. Ahmad Panduwijaya is welcome to lead us in prayer.
Bapak Ibu yang kami hormati, acara dilanjutkan dengan pembacaan doa yang akan dipimpin oleh Bapak Ahmad Panduwijaya. Kepadanya disilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, please let us bow our head for a moment. Pray to God Allah Subhanahu wa Ta'ala so that our international conference can be precious to all. I will lead this prayer based on the teaching of Islam. So, who are not Muslim, you can pray according to each your beliefs. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Hamdan syakirin, hamdan na'imin, hamdan yu'afi namahu wa yukafi mazidah. Ya Rabbana lakal hamdu wa lakal syukru kama yanbaghi li jalali wajhika wa 'azimi sultanik. Allahumma inna nas'aluka salamatan fid dinina wa afiyatan fil jasadina wa ziyadatan fil ilmina wa barakatan fi rizkina wa taubatan qabla mautina wa rahmatan indal mautina. Allahumma ighfir lana wa liwalidina walil muslimina wal muslimat wal mu'minina wal mu'minat al ahya'i minhum wal amwat innaka sami'un qaribun mujibud da'wat ya qadiyal hajat. Oh Allah, today Wednesday, October 25, 2023, in this beautiful place we gathered here to bring about an international conference on informatics, mechanical, industrial and chemical engineering, ICIMICE 2023. Make this international conference as useful science assembly, as a medium of sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our lives, broaden our knowledge, shine our ideas, and lead us to be successful, productive persons, which in turn will boost dignity of our nation. Oh Allah, guide and bless our hearts and our minds with the light of your guidance. Impart your supreme wisdom upon our activity. Help us to speak our mind clearly. Help us to listen to each other, respect to each other, love each other, so that we are not included to blessed persons. Oh Allah, protect us from unintended temptation. Show us the right path and give us knowledge and strength to perform good things equally. Show us, make it clear that bad things and give us knowledge and strength to avoid them. Oh Allah, you are the one who can fulfill our dua. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Subhanaka rabbika rabbil izzati amma yasifun. Wassalamun alal mursalin walhamdulillahi rabbil alamin. Amin amin ya rabbal alamin. Wallahul muwaffiq ila aqwamit thoriq. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, we will have a picture shoot. Will you please turn your camera on?
Hadirin yang berbahagia, acara dilanjutkan foto bersama. Kepada seluruh partisipan yang ada di via Zoom untuk bisa menyalakan mode kamera karena akan ada sesi foto bersama. Baik, untuk slide pertama kami izin dalam hitungan 1, 2, 3. Baik, slide selanjutnya. Satu, dua, tiga. Baik. Slide 3, 1, 2, 3. Slide 4, 1, 2, 3. Slide 5, 1, 2, 3. Slide 6, 1, 2, 3. Kami ucapkan terima kasih. Bapak Ibu hadirin yang kami hormati, kami sampaikan terima kasih kepada Bapak Rektor, Wakil Rektor, dan Dekan Fakultas. Dan kami sampaikan terima kasih dan bisa melanjutkan kegiatan Bapak. Bapak Ibu hadirin yang kami hormati, demikianlah rangkaian pembukaan International Conference on Informatics, Mechanical, Industrial, and Chemical Engineering dan Seminar Nasional Sains dan Teknologi 2023. Kami selaku pembawa acara meminta maaf apabila ada kesalahan kata, tutur kata, dan saya Restu Afrianto dan juga partner saya Adin pamit undur diri. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Excellencies, ladies and gentlemen, we are now continuing our meeting to the next agenda, that is to hear the keynote speech which will be delivered by Professor Ito Kozo from Department of Applied Chemistry, University of Tokyo, Mr. Willy Bukletin, PhD, from Cavite State University, Philippines, and Ferry G, PhD, from Edith Cowan University, Australia. Dr. Indah Hartati, STMT, will moderate our presentation and discussion.
Acara dilanjutkan dengan keynote speech yang akan disampaikan oleh Profesor Ito Kozo dari Department of Applied Chemistry, University of Tokyo, Mr. Willy Buklatin, PhD, dari Cavite State University, Filipina, dan Ferry G, PhD, dari Edith Cowan University, Australia. Dan pada kesempatan pagi hari ini akan dimoderatori langsung oleh Ibu Dr. Indah Hartati, STMT.
Dan tentunya sebelum dimoderatori akan saya bacakan terkait dengan kurikulum vitae-nya terlebih dahulu. Bachelor in Diponegoro University, Chemical Engineering dari tahun 1999 sampai 2003, dan Magister di Diponegoro University, Chemical Engineering 2008 sampai 2010, Doctoral di Gajah Mada University, Chemical Engineering 2017 sampai 2021. Selanjutnya untuk research di tahun 2022, research mengenai engagement of biogas production from Ananas Cosmosus in Mir West Bay Applied LSS and SSS. Publication di tahun 2021, Micro-Waste Assist Urea Based Hydroponic Pretreatment of Rice Straw Experimental Data and Mechanistic Kinergic Model. ESG Omega. Selanjutnya, Mericostalin, Cellulose Production by Acid Hydrolysis of Hydrotropic Restraw Pulp, di IOP Conference Series Earth and Environmental Sciences. Untuk oral presentation, yang terakhir berdiri adalah ASEAN University Network, Southeast Asia Engineering Education Development Network pada November 2018, The Regional Conference on Chemical Engineering 2018, Mathematical Modeling and Simulation of Hydrotropic Delignification.
Kepada yang terhormat Ibu Dr. Indah Hartati STMT, waktu sepenuhnya saya silakan.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone, respectable the Rector of Wahid Hasyim University, the Honorable Dean of all Faculty in Wahid Hasyim University, the Honorable all lecturers of the Engineering Faculty, and the Honorable all of the participants of the seminar. Ladies and gentlemen, I'm Indah Hartati, the moderator of today's seminar. I'm very pleased to see you here and welcome all of you to this international conference on informatics, mechanical, industrial, and chemical engineering 2023. Today's seminar is about the impact of Industrial Revolution 4.0 to Society 5.0's digital transformation. Ladies and gentlemen, our speakers for today's seminar are Associate Professor Willy C. Bukletin, PhD, from College of Engineering and Information Technology, State University. Prof. Ito Kozo from Department of Applied Chemistry, University of Tokyo, and Associate Professor Ferry G. PhD from School of Business and Law, Edith Cowan University. Before the presentation begins, let me inform how the presentation will be going on. First, Associate Professor Willy C. Bukletin, PhD, will be invited to present the material. Prof. Ito Kozo and Associate Professor Ferry G. PhD will then present their presentation respectively. After the entire three keynotes presented their materials, there will be question and answer session and then followed by conclusion. First of all, allow me to welcome and briefly introduce to you our first speaker. Associate Professor Willy C. Bukletin, PhD, is from College of Engineering and Information Technology, State University. He graduated with a doctoral degree in Technology Management from Technological University of the Philippines, Manila. He is highly organized and detail-oriented ASEAN Engineer Register with 7 years experience in the industry, focusing on inventory management and control, warehousing, planning, material control, quality assurance, production system, process analysis and improvement. He has also 18 years experience in the academy as an industrial engineering faculty member, and currently now Associate Professor Willy C. Bukletin, PhD, is the Dean of College of Engineering and Information Technology of State. Associate Professor Willy C. Bukletin, PhD, is also an AACCUP accreditor and CHED-RQ-AT evaluator. Ladies and gentlemen, please welcome Associate Professor Willy C. Bukletin, PhD. Associate Professor Willy C. Bukletin, PhD, the time is yours. We'll be giving you 40 minutes for presentate your presentation. Time is yours. Prof. Willy, you are muted, brief. Now we have you, Prof. Willy. Yes, Mr. Willy. Please present your material. We haven't heard your voice, Mr. Willy. Yes, Mr. Willy, please. Good morning, Mr. Willy.
Okay, can you hear me loud and clear?
Yes.
Okay, so to the officials of Wahid Hasyim University, esteemed faculty members and staff, outstanding guests, fellow researchers and participants, so good morning. So I am very much grateful to be part of this international conference on informatics, mechanical, industrial, and chemical 2023. So I know today is an important moment for your academic community as we come together to celebrate and share the innovative researches and discoveries that we have been diligently working on. So today, as we engage on this event, we will be able to explore into groundbreaking outcomes that will not only contribute to scientific advancement, but also have the ability to transform industries and improve lives. So my topic focused on revolutionizing inventory management, analyzing the impact of Industrial Revolution 4.0 on Society 5.0's digital transformation. So by the way, I am Willy Siboclatin, so from Cavite State University, Philippines. So for the presentation outline, we have the Industry 4.0 versus Society 5.0, importance of digital transformation, and also we have the inventory management, and then the Industry 4.0 key technologies and their impact to inventory management, and also the principles of Society 5.0 on inventory management, and also the conclusion. To begin with, so we have the comparison between the Industry 4.0 and Society 4.0. So as we all know, the terms Industrial Revolution 4.0 and Society 5.0 so represent two different but interconnected concepts, with one primary focus on industrial and technological advancement, and the other on societal and the human-centric transformation. So for the Industry 4.0, often referred to the Industry 4.0 or the fourth generation industrial revolution, so our focus primarily on the transformation of industries and the manufacturing processes. So usually, when it comes to the Industry 4.0, it is characterized by the integration of the advanced technologies. So the common one, we have the Internet of Things. I know you are also familiar with that, or the IoT. And the very familiar also, the artificial intelligence or the AI, the big data, and the automation into manufacturing and also in the production. So usually, when it comes to the Industry 4.0, so we embrace it because our aim is to improve the efficiency, particularly when we are referring to the manufacturing side. And also, we're going to reduce production cost and enhance economic productivity by enabling smart factories and the supply chain. So that is for the 4.0. And for the Society 5.0, so usually the concept originates all from Japan and places emphasis on the holistic transformation of the society itself, not just the industrial or the economic aspect. So usually, in terms of the Society 5.0, it envisions a future where technology is harnessed to address those societal changes. And also, part of the Society 5.0, so we focus on the improvement of the overall quality of life of the individuals. That's why the focus is more on the human-centric. And also, part of the objectives or our goal for the Society 5.0, it's more on to create a society that is inclusive, sustainable, and human-centered. So as we all know, one of the most important resource, particularly in any organization, is the human resource. While also it incorporates, when we are focusing on Society 5.0, so it incorporates in advanced technologies. And the primary objective is to use those technologies to solve issues and problems related, for example, to the aging population, let's say, to solve problems in terms of the healthcare, education, and also the environment. So in terms of the importance of digital transformation, so when we say digital transformation, so it is crucial in the modern business landscape. Of course, we need to focus more on the enhanced efficiency and productivity. So when we say enhanced efficiency and productivity, so we're going to optimize business process. We're going to automate those repetitive tasks that will not add value to the operation. And we're going to streamline the process or the operations when it comes to the enhanced efficiency and productivity. So it's more on the improve the customer experience when we are referring to the digital transformation. So when we say improve customer experience, so usually we're going to enable business to provide more personalized and convenient services to their customer. Meaning to say, we need to satisfy the needs and wants of our customer. This enhances customer satisfaction, the loyalty, and retention. And of course, there is a significant effect in terms of our profit or the income. And then it's more on the data-driven decision-making. Through digital transformation, so different organization, whether it's more on the manufacturing or the service side, can collect and analyze vast amount of data. So meaning to say, through that data collected, we will come up to a particular correct and right decision, and it will empower better decision making, helping businesses anticipate the market trends and customer needs in terms of digital transformation. Also, part of the importance of digital transformation is more on the global reach. So, digital technologies break down geographical barriers, allowing business to reach a global customer base. It can be product from other countries or nation, can be also used or purchased by different individuals. And also, through digital transformation, when it comes to global reach, this expands the market opportunities and diversifies the revenue sources. We can order products, for example, from Indonesia or from other Asian country, so that we can also have the expand market opportunities and increase the revenue or the income. Another part of the digital transformation, it's more on the innovation and agility. So, of course, through innovation and agility, it will foster a culture of innovation and agility. So businesses can adapt to changing market conditions more swiftly and experiment with new ideas and products. And another one, part of the importance of digital transformation, it's more on the competitive advantages. Of course, those multinational those companies who can afford to avail those available technologies can embrace the digital transformation, gain a competitive edge. Okay? And also, part of the competitive advantage, so they can respond to market change. And also, we can meet those consumer demands. And also, the emerging technologies more effectively than those that lag behind, especially those companies that have enough capital to purchase in order for them to embrace those latest technology. Okay, so when we say inventory management, so we will focus, for example, in terms of the inventory types, the inventory levels, and of course, present is the inventory cost. Inventory types can be categorized into various types. For example, the raw materials can also be an example when it comes to the types of inventory. The work in progress or products that are semi-finished, for example, already processed to the next station in the production. And also finished goods can also some of the common type of the inventory. Through this inventory type, so of course we need to have the proper management. So of course there are different types of items or supplies to be inventoried, and also those type is crucial to support the production and meet also the customer demand in order for us to deliver the right quantity and also the right time to our customer. Another, when we say inventory levels, so we need to maintain the right balance of inventory is very vital. We need to consider those fast-moving products. We need also to consider to monitor those slow-moving products. And excess inventory ties up capital and storage space, especially those slow-moving products stored in our warehouse. While inadequate inventory can lead to stockouts and also resulting to customer dissatisfaction. So inventory management, so one important aspect. So it seeks to strike the right balance. Of course, part of our goal is we're going to produce the right quantity as per order by our customer. And we need to have the inventory cost. So part of the inventory management related to cost, so also involves minimizing the holding cost. So what are those example ng holding cost? Example, the storage of the excess product, the insurance, and also present the ordering cost. For example, the procurement, how many times we order product? Are we going to, for example, practice order is what we call the standard number of orders, for example, per month or per quarter. And also set up time. The more time we set up a new product to the production to a particular machine, it will incur or entitle a cost. So through that inventory management, so we need to reduce this cost without compromising the product availability, and also the quality is our main objectives for this inventory management. Another part of the inventory management, so that is the demand forecasting. Okay, we need to forecast, for example, whether it is a raw materials ordered to our supplier, and also similar, whether it is, for example, a finished product that is being ordered by our customer. So the accurate demand forecasting is essential to avoid the overstocking or the understocking of a certain supply. So usually those people in charge in the inventory, so some of you, for example, will use the historical data, and some of you, for example, will use the market insights to predict the demand, and we're going to plan it accordingly. Another, so part of the inventory management, it's more on the use of technology and software. So inventory management often relies on specialized software and technology to track the inventory levels. Some of you were going to automate the reordering, and of course, to optimize the supply chain. So through this technology and software, so it will help in a real-time monitoring and decision-making. Another is the just-in-time, which is common, for example, in some of the companies. And then through JIT inventory system, so it is a strategy where inventory is ordered or produced only when it is needed. Okay? And through that, the application of JIT, since we're going to produce or order only when it is needed, so it will possibly reduce the holding cost. And also, this approach relies heavily on efficient supply chain management. Another, that is the safety stock. Okay? So, in order for us to eliminate or to lessen some of the uncertainties in terms of the demand and supply, so some of the companies often maintain a safety stock, or another term for the safety stock, so that is a buffer to prevent the stock outs. The level of safety stock is a key inventory management decision. Okay? So part of that, in terms of the inventory management, so we need to have the Industry 4.0 key technologies and their impact on inventory management. Of course, the common one, the IoT or the Internet of Things. Okay? So IoT or the Internet of Things, characterized by the interconnectivity of devices, such as sensors, has several notable impacts on inventory. The first one is more on the real-time monitoring. So of course, there is a significant advantage of inventory management lies in the asset tracking, specifically through the implementation of RFID tags, which is common, as opposed to traditional the barcode scanning and manual data entry. Okay? So through these RFID tags facilitate wireless registration, enabling the precise acquisition of data and the monitoring of items at any point within the supply chain. Okay? And then another part of the Internet of Things, it's more on the efficient ordering. So through the integration of the IoT or the Internet of Things into various aspects of supply chain and inventory management, it has a significantly improved the efficiency of the reordering process. So usually, the application or the importance of IoT ensures a streamlined supply chain by facilitating continuous data transmission, preemptive action, and efficient logistic management. So when it comes to this Internet of Things, so overall, IoT's data-driven approach revolutionizes inventory management, leading to more efficient reordering practices. Another, technologies and their impact on inventory management. So that is the artificial intelligence and machine learning. So usually, when it comes to the AI and then the machine learning, so we focus on the advanced demand forecasting. So AI and machine learning greatly impact demand forecasting by providing more precise predictions considering various factors such as seasonality and the consumer behavior. So because there are products that are being offered to the market seasonal, and also we are also based on the consumer behavior, the consumer buying behavior. So the artificial intelligence driven forecasting benefits inventory management as well as a sound production planning. And also we can focus more on the cash flow insight as well as our target market and a strategic decision. So when it comes to the optimization, so machine learning is proposed as a tool for optimizing inventory management by introducing a novel framework that leverages decision tree models to approximate item level inventory performance, taking into account demand patterns and the replenishment policies. Okay? So this approach in terms of the AI or the machine learning, so this approach offers faster data-driven approximations in contrast to the conventional inventory simulation or the manual. Okay? Another, so we have the automation and robotics. So when it comes to the automation and robotics technology, it influences inventory management in the following ways. Of course, through automation and robotics, it will have a faster order fulfillment. Okay? So warehouse automation encompassing both physical and digital aspects plays a crucial role in enhancing the order fulfillment efficiency. So of course, through that particular faster order fulfillment, if optimizes various warehouse processes like receiving of items or supplies, returns, put-aways, picking, sorting, replenishment, packaging, and even shifting or shipping. Okay? Another, so part of the industrial 4.0 key technologies, it's more on the optimized warehouse operation. So the impacts of robotics and optimized warehouse management is a very profound aspect. Okay? It enables automated picking and packing, inventory tracking and management, efficient autonomous mobile robots for goods transportation, and even for the collaborative robots that work alongside humans. Okay? And then furthermore, when it comes to this optimized warehouse operation, it optimizes the warehouse layout, generates valuable data for analytics, and offers scalability and flexibility in adapting to changing business needs. So another, so we have what we call the blockchain technology. So what are the possible impact pertaining to the inventory management? through the application of this technology or the blockchain technology, it will enhance trust, and of course, it will reduce the possible error. Okay? So the blockchain technology holds significant potential for enhancing trust in inventory in supply chain management. So usually when it comes to this blockchain, so usually the traditional database technologies present several challenges for recording, for example, the financial transaction. Okay? So for instance, in terms of the application of the blockchain technology, so for instance, we're going to consider the scale of a property or the sale of a certain property. Once the money is exchanged, ownership of the property is transferred to the buyer, right? Individually, the buyer and the seller can record the monetary transactions, but neither source can be trusted, whether it's a legit or a scam. The seller can easily claim they have not received the money even though they have. And the buyer can equally argue that they have paid the money even if they haven't. Okay? So that is, for example, the traditional way. In the application of the blockchain technology. Okay? So the traditional database technologies present several challenges for recording financial transactions. For instance, consider the sale of a property, for example. Okay. So we need to record the transaction through the application, for example, of the blockchain technology. And then through the technology, so we can show the movement of physical or the digital asset from one party to another in a blockchain network. Of course, we need to record who was involved in the transaction, what happened during the transaction, when did the transaction occur, where did the transaction occur, why did the transaction occur, and of course, how much of the asset was exchanged. Okay? So through that particular application of the blockchain technology, so let's say once the participant have reached a consensus transaction on the blockchain are written into blocks equivalent to the pages of a ledger book. Okay? We need, meaning to say, there is a what we call the public blockchain network, the private blockchain network, and of course, the hybrid blockchain network. And part of the reduction in errors, so through this blockchain technology, so inventory system significantly contributes to the reduction of errors by automating the order fulfillment through smart contracts, for example, maintaining real-time and tamper-proof data accuracy, offering secure and immutable records, facilitating verification and audibility that ensures data consistency, and sending automated notification and alerts based on specific conditions. This technology-driven approach minimizes the risk of a possible human error. And of course, it will enhance the data reliability and improves the overall supply chain accuracy, making it a valuable tool for error reduction in inventory management. Okay, so principles of that particular Society 5.0 on the inventory management. Okay, so a while ago, we said that's more on the human-centered. So transition to a human-centric society. Of course, through that principles of that particular Society 5.0, when we can relate that to inventory management. Of course, it will enhance the customer-centric inventory management. Okay? So in Society 5.0, the focus is on a human-centric approach, means that the businesses prioritize meeting customer needs and providing exceptional service. Okay? So the inventory management can align with this by ensuring the right products are available at the right time to satisfy the customer demand to enhance their experience. That is for the Society 5.0. And when it comes to the customer-centric supply chain and demand-driven approaches, along with the attribute-based planning and ergonomic dashboards, emerge as essential tool for success of a certain organization. So usually in terms of the Society 5.0, so this emphasizes how leveraging technology and then the customer-focused methodologies is indispensable for companies striving to maintain sustainability, enhance competitiveness of a certain organization, and minimize errors in their inventory and demand management processes within the dynamic landscape of a Society 5.0. Another, it's more on the integration of technology and humanity. Of course, we have the human-centric inventory decision-making. So we need to balance efficiency and empathy and collaboration across the supply chain. Pertaining to the human-centric inventory decision-making, of course, so for example, we're going to integrate, or in terms of the integration of technology and then the humanity in inventory management, usually it involves the using of the available technology to support the enhanced human decision-making. So given na yung mga data-driven algorithms and the automation, it will play a significant role. The final decision, consider the human elements such as we're going to understand the customer preferences and then the supply chain nuances. Another, we need to balance efficiency and empathy in the Society 5.0. So, meaning to say, the use of technology enables efficiency in inventory management by optimizing the processes. But the human element, including empathy to customer needs and ethical consideration, guides decision on what to stock, how to package a certain product, how to minimize waste, and of course, we need to consider the environmental impact. And then for the collaboration across the supply chain, so again, through the integration of technology and humanity, also extends to collaboration with suppliers and other partners. Technology streamlines communication and data sharing, while human relationship and trust are the fundamental in ensuring the supply chain runs smoothly and ethically. Okay? So primarily, that is the focus of the Society 5.0. Another, so since we focus, for example, more on the efficiency plus the empathy, and of course, the collaboration across the supply chain, we need to have the sustainable inventory practices and also the ethical sourcing and inventory transparency. For the sustainable inventory practices, okay, so when it comes to Society 5.0, so it encourages sustainability. Business can adopt sustainable inventory management practices, such as reducing the excess stock to minimize waste, choosing the eco-friendly packaging materials, and we need to optimize transportation routes to reduce carbon footprint, all of which contribute to overall well-being and sustainability. Of course, through these sustainable inventory practices, businesses or different organizations aim, or the goal is to procure materials and products from suppliers who adhere to environmentally responsible practices and ethical labor standards. So, reducing the environmental impact also involves adapting the eco-friendly packaging. Companies are switching to recyclable, biodegradable, and reusable packaging options that surely reduce waste and promote sustainability. Okay? And for the ethical source and inventory transparency, so a focus on sustainability also includes the ethical sourcing of materials. Businesses can use technologies such as the blockchain to track the origins of products and materials, ensuring they meet the ethical and also the sustainable standards. Okay? Different organizations or companies focus on transparency in their inventory management practices. Okay? They share information on transparency in their inventory communicated customers, and also companies focus on their transparency in terms of different practices. Accountability ensures that companies live up to their well-being and a sustainability commitments. Okay, so what do we mean by the sustainability commitment? Meaning to say, companies are increasingly focused on building ethical supply chains. So of course, through that building ethical supply chains, so this include ensuring that there is a fair labor practices, fair wages, and of course, one of the most important, a safe working condition for workers throughout the supply chain. And through that particular, what we call the ethical considerations, it will extend to all aspects of production, from raw materials up to the finished product. Okay, for the conclusion, so the interplay between Industrial Revolution 4.0 and of course the Society 5.0 has ushered in a transformative era of the digital innovation. With a focused lens on inventory management, as we explored the convergence of these two paradigms, has resulted in significant impacts on inventory practices, shaping the way businesses operate and cater to the value of Society 5.0. So of course, this unique blend of advanced technologies and a human-centric approach is changing the way we think about, manage, and optimize inventory. So meaning to say, as businesses and society move forward, it's clear that this fusion of Industry 4.0 and the Society 5.0 values is not merely a trend, but a fundamental shift in the way we approach inventory management. By embracing this advancement, we can not only operate more efficiently, but also contribute to the betterment of society by reducing waste, improving transparency, and of course, enhancing the well-being of both businesses and a certain individual. The convergence also of the Industry 4.0 and Society 5.0 with a focus on inventory management reflects a broader shift towards a more holistic, sustainable, and human-centered approach to technology and of course to business. By harnessing the power of these technologies and aligning them with the value of Society 5.0, we can look forward to a future where inventory management is not just efficient, but also deeply attuned to the needs and well-being of individuals and society as whole. So with that, thank you and good morning.
Thank you very much, Associate Professor Willy C. Bruketin, PhD, for giving us such informative and interesting information and presentation. So, ladies and gentlemen, now we've come to the second speaker, Prof. Ito Kozu. Prof. Ito Kozu is from Department of Applied Chemistry, University of Tokyo. Prof. Ito graduated with a doctoral degree in engineering from the University of Tokyo. Prof. Ito Kozu specialized in research of soft matter comprised of variety of large molecular substances such as polymers, liquid crystals, molecular membranes, biopolymers, colloids, and granular matters. The main objective of his research is to realize ecologically compatible and highly functional materials by controlling the structure and properties of soft matters in time and space. Ladies and gentlemen, please welcome Prof. Ito Kozu. Prof. Ito Kozu, the time is yours.
Thank you very much for kind introduction. Can you hear me? Can you hear me? Okay, may I start my presentation?
Okay, Prof. Ito Kozu, we can hear your voice. You may present your presentation, please.
Okay, thank you very much for kind introduction. And good morning, everyone. I'm Kozo Ito, a professor at the University of Tokyo, and also I'm a fellow at the National Institute for Materials Science. Today, I'd like to talk about sliding materials for circular economy. So this shows the outline of my talk today. Let me introduce the sliding materials, which we invented about 20 years ago. Then I'm now managing, I have been managing, and I'm now managing a big national project called Impact Program and Moonshot Program. So first, after my short introduction of sliding materials, I'd like to show you some remarkable achievement by the Impact Program. Here, we developed new tough polymers for automobile by the close collaboration between the Japanese chemical companies and academia. Then I'm running the Moonshot program now. Here, we are now developing marine biodegradable plastics. Okay, and also I'm now I start to manage the new big project to SIP program. Here, this target is a circular economy, but due to the limitation time, so I'd like to skip these topics. Okay, let me start. As you know well, circular economy is a new economic model that uses things for a long time and circulate waste as resources instead of the conventional linear economy model of mass production, mass consumption, and mass disposal. My project is closely related to the circular economy. In the Impact Program, we have developed remarkably tough polymers for automobile. So when we reuse the plastics, so we need to improve the mechanical property to use the plastics for a long time. So the outcome in the Impact Program can be applied to such a very, very durable polymers, as I mentioned later, as I will mention later. And also, in the Moonshot project, we are now developing the very biodegradable plastics. This is because some plastics cannot be collected, and they are spread in the environment by accident. So for typical example is a tire wear powder. So, but we have to circulate these uncollected waste as resources to the water and carbon oxide. And this this water and carbon oxide is transformed to the biomass-based polymers. Okay. So now let me introduce sliding materials briefly. This schematically shows the structure of the chemical cross-linked polymers. Conventional chemical cross-linking gels have a large heterogeneous structure. Stress concentrates on the shorter chains because of the large heterogeneous lengths of network strand. So stress concentration easily occurs in the usual chemical gels. To solve this problem, we adapted the mechanically interlocked system. Mechanically interlocked molecular architecture is defined by the connections of the molecules not through traditional bonds, but instead as a consequence their topology. So they include trefoil knot, catenary, rotaxane, and polyrotaxane. They are expected to be applied to the molecular switch, molecular shuttle, and molecular motor, and so on. About 20 years ago, in my laboratory, we invented a new network structure, topological supermolecular network called sliding materials. Here, we cross-linked the only cyclic molecule, cyclodextrin, in polyrotaxane. Then we formed figure-of-8 junctions. These figure-of-8 cross-linking can move freely in a polymer network. So large deformation is possible, keeping topology of polymer network. This is the sliding materials. Okay. So here the situation is drastically changed. On tensile deformation, the figure-of-8 junction cross can pass the polymer chains freely to equalize the tension of the threading polymer chain, just like pulleys. So the stress dispersion automatically occurs in the sliding materials. Various peculiar mechanical properties of sliding materials come from this pulley effect we support. So let me show you the recent progress of the sliding materials. So this is the synthesis scheme of the polyrotaxane. When we mix the alpha cyclodextrin, cyclic molecules, and polyethylene glycol in water, and these cyclic molecules is formed inclusion complex like this self-assembling. So then we obtained about 25% coverage polyrotaxane like this. But recently, we replaced the alpha cyclodextrin with hydroxypropylated one. Then we obtained the 2% coverage polyrotaxane like this. So now that we can control the inclusion ratio very precisely in 1% increments. Okay. So this shows a comparison of the mechanical properties of the high coverage polyrotaxane gels and low coverage polyrotaxane sliding materials. High coverage sliding gel shows a small elongation at break like this. But low coverage polyrotaxane gel shows a very, very long extension, large extension ratio at break. So you can see that this low coverage polyrotaxane gel, sliding gel, cannot be cut with a usual cutter or woody stick. At that time, so we didn't know why these low coverage sliding materials shows a very, very high toughness. Recently, we clarified, we found the molecular mechanism of the high toughness of the low coverage sliding gels. Okay. So in the low coverage sliding gels, so this stretch-induced crystallization occurs. So sliding gel consists of PG and cyclodextrins. When stretching the low coverage sliding gels, cross-linked cyclodextrin moves in a long distance and uncovered PG chain to form the close-packed structure to be crystallized. This is called stretch-induced crystallization. When the stress is released, this SiC crystal disappears rapidly, which means this means no or very small hysteresis in the stress strain curve. This shows the actual stress strain curves. You can see that there's very, very small hysteresis. And stretch-induced crystallization appears at the elongation ratio over the 9 times in length. So this shows the work of fracture versus instant recoverability of the various tough gels. Conventional tough gel shows a very, very high work of rupture, but low instant recoverability. But our low coverage sliding gel shows a very high work of rupture, high strength, and instant recoverability at the same time. This is a difference in the mechanism of the toughness. Our low coverage sliding gel has a self-reinforcing effect by the stretch-induced crystallization. Okay. So this is summary of my talk, first part. So low coverage ratio sliding gel shows yields a self-reinforcing sliding effect. And this is the first discovery of stretch-induced crystallization for gel materials. Okay. And next, I'd like to talk next topics. Our concept of sliding material can be applied not only gel materials, but also the hard resins. This is an example of the application of sliding materials, polytexan, to the PMMA transparent resins. This work was collaborated with Professor Su at Texas A&M universities. Here, we add a very, very small amount of polytexan 1% or 2% to usual PMMA resins. And we measure the scratch resistance of the PMMA resin without and with polytexan. Okay. So this shows the stress strain curve of the PMMA resin with or without polytexan. When we add a small amount of polytexan to PMMA resin, you can see the Young's modulus is not changed, but the elongation at break is drastically increased about twice by the very small amount of polytexan. And so this shows the scratch resistance test results. So with the vertical axis represents the critical load of the crack formation. Usual PMMA resin shows the crack, yields a crack at the critical load of 60 Newton, about 60 Newton. But when we add a very small amount of the polytexan, about 2% to the PMMA resin, you can see the critical load increase over twice. So this means that a small amount of polytexan improves the scratch resistance of PMMA resin drastically. Okay. So polytexan is now applied to the scratch coating and some golf balls. In these golf balls, sliding material is coated to the on the surface of golf ball. This golf ball is used by the Japanese top player Hideki Matsuyama. You can see the full effect of the in the commercial film of the golf ball. Okay. So now I'd like to talk about some achievement by the impact program. Impact program is one of the Japanese largest national project, and by the directly by the Prime Minister. Prime Minister Shinzo Abe started this project. The company selected the 12 program manager, including me, that their target is different. My target is toughen the polymeric material for automobile. So as you know, where the implementation of the composite is going from plane to automobile. In old days, the plane body was made from the duralumine, but recently various composites such as CFRP is used for the airplane body. This trend is spreading to the automobile. But so the market of composite is expanding by these new applications. But there are some problems such as high productivity and low cost, and also the compatibility between the hardness and ductility is a serious problem. Generally speaking, the harder polymers are, the more brittle they become. Okay? So to solve this problem, we are now started a very big national project to improve the mechanical properties by the close collaboration with a company, between the companies, Japanese chemical companies and academia. And Toray, Sumitomo Chemical, Bridgestone, AGC, Mitsubishi Chemical, these chemical companies joined my project to improve the mechanical properties. Let me show you some achievements, some outcomes by this project. This is performed by the Toray. So they used the polyamide resin. As you know, where elongation break and hardness has a trade-off relation, but they incorporated the sliding materials in the polyamide resin. They achieved about they successfully increased the elongation break about 10 times at almost the same hardness. And they performed the bending durability test. Usual polyamide resin shows bending about 2,000 bending times at break like this. But Toray incorporated protection into polyamide resin. The bending durability is improved drastically about 50 times. So this shows the ion drop test. Conventional polyamide resin is brittle like this, but developed polyamide resin with protection doesn't collapse by this ion drop test. So this technology is also effective to the composite. These two polyamide resin has about 30% glass fiber, but you can see the polyamide composite resin with protection doesn't collapse this test. So this protection is also effective for that CFRP. Okay. Now let me show you another achievement by the Bridgestone. So when you stretch rubber, then the crack propagate very, very slowly like this. But when you stretch rubber more stronger, then the crack propagate becomes very fast. This is called crack propagation transition. The Bridgestone incorporated the concept of double network gel by Professor Gon at Hokkaido University. They successfully increased the transition energy about 4 times. Then the no crack propagation occurs at stronger tensions. So they performed the demonstration test. You can see these two rubber is stretched in the vertical direction. This upper is a standard rubber and lower is developed rubber. And they cut the end of the rubber, and you can see standard rubber shows a very, very fast crack propagation. But this developed rubber doesn't show such a fast crack propagation. Crack propagates very, very slowly. These two rubbers have almost the same stress strain curves, but the crack propagation behavior is truly different. And finally, they performed the verification test with rubber caterpillars. And they found that the developed rubber decreased the wear rate about 60%. This means tire wear powder is also reduced when we use these new tires. Okay. So this is summary of the main achievement in our impact program. Every company successfully developed new polymers by the strong collaboration with academia. Finally, we constructed a concept car using these rubbers. So for this concept car has a weight of 850 kilograms, about 60% of usual car automobile. And the polymer content is very, very high. It's almost 45% by weight and 85% by volume. Usual car use only the 10% of plastics by weight. So this car can be regarded as a plastic car, and the max speed is about 150 kilometers per hour. And we actually drive this car in the circuit course, and this car is made from almost plastics, but it's very, very tough. So you can drive this car at 150 kilometers per hour. Finally, I'd like to show you the very funny video. So I have a chance to make a presentation in front of a Prime Minister and his cabinet member. So he was the Prime Minister Shinzo Abe, and he was the next Prime Minister. So before my presentation, I showed the Prime Minister Shinzo Abe the self-healing resin, and we cut it in front of him. And during my presentation, the student is attached to this self-healing resin. And after my presentation, he showed this resin. And before my presentation, this resin was cut completely. But he was applied to this resin is self-healed completely. So, and then I asked Shinzo Abe, Prime Minister Shinzo Abe, to join the experiment of the polymers. So I asked him to press this very brittle gels. It contains about 80% of water. And usually gel is brittle. But so in my project, we create very, very tough gels, like low coverage polyethylene gels or double lateral gels. And he asked him to hit with a hammer, but gel is not cracked. So he was very delighted to join this polymer experiment. And it was very successful presentation. After my presentation, my budget was increased by about $10 million. Presentation is very, very important, I think. Finally, I'd like to introduce the current project I'm now managing. This is called Moonshot Program. Here, we target is now marine biodegradable plastics in ocean. We'd like to make such plastics from non-food biomasses. Okay. As you know, where the plastic pollution is now a serious problem all over the world. Fishing gears, tire wear powder, textile waste, thrown away, going to the ocean in the to frighten the preservation of the ocean. I think it's also a serious problem in Indonesia. Okay. To solve this problem, so we developed a new polymers. So uncollected plastic, tire wear powder, textile waste, and fishing gear are serious problem for global environment. But problem is the durability, and degradability is a trade-off relation in plastics. So some polymers are degradable in ocean or degradable in soil, but these polymers, or especially bio-based polymers, is not so tough. And on the other hand, there are tough polymers such as polypropylene and polyethylene, but this polymer is very, very tough, but they are not degradable, so they yield microplastics in ocean. And so we'd like to develop the ideal polymers by the novel concept. And these polymers is very, very tough, and we can use for a long time. But when they are accidentally thrown away in the ocean or are going to ocean, and it rapidly breaks to the carbon dioxide and water smoothly. Now that there are no such polymers, so we'd like to developed these polymers by the strong collaboration between the companies and academia. In this project, so major Japanese chemical companies joined, such as Mitsubishi Chemical, Bridgestone, Teijin, Kureha. And I'd like to show you some achievement by these companies. And so this shows biodegradable index, biodegradable ratio of the DM polymers. So small lengths, shorter DM polymers in biodegradable, but long DM polymer doesn't have the marine biodegradability. But we introduced some biomass-derived unit or biodegradable unit in the DM polymers. Then you can see the biodegradability is improved drastically. So the biodegradability improved by more than 10 times with the degradable unit introduction to the rubbers. Okay. So, and this is another example by the Bridgestone. So cross-linking is also the hindering the biodegradation. So we introduce some reversible and we introduce some non-covalent junctions for the cross-linking to the rubbers. And so this is a non-covalent and cross-linking junctions. Okay. So then you can see this cross-linked rubber shows the biodegradability absolutely different from the usual rubbers. And also, the mechanical property is improved drastically by introduction of these non-covalent junction, non-covalent cross-link to rubbers. So both toughness and biodegradation are significantly increased by introduction of the reversible and degradable cross-links. Okay. And also, this is the achievement by Kureha. So they are increased the strength of the fishing lines. So there are some degradable fishing lines, but it's very brittle. The strength is not enough. And but the Kureha is collaborating with academia, and they successfully improved the mechanical properties, the strength of fishing line up to the level of the non-degradable fishing lines such as nylon and PET. And also, this fishing line shows the biodegradability. When fishing line is cut and the fishing line is sinked in the in the ocean, and so it's smoothly degradable to the carbon oxide and water. Okay. So finally, I'd like to show you some improvement of the mechanical property with polylactic. So here we improve the mechanical property of polylactic acid by the small addition of polylactic. Here we compare the two additives, polylactic and usual graft copolymer, conventional graft copolymers. These two additives has a similar components, But the difference is polytexan consists of cyclic molecules. But this graft copolymers has a graft chain fixed onto the main axis chains. This is difference between these two additives. So this shows the stress strain curves of the PLA and PLA with graft copolymer and PLA with polytexan. And you can see the usual neat PLA is brittle polymers. So the elongation to break is very, very small, about 50%. And we add about 5% of graft copolymer to the polylactic acid. Then you can see the elongation to break is improved about twice. And also we add 5% of polytexan to the polylactic acid. Remarkably, you can see the elongation to break increased about 20 times by the small addition. So I'd like to speak this slide. So we are now investigating the toughening mechanism of the polytexan in polylactic acid. And here we found the crates is very, very stable by the small addition of polytexan into the polylactic acid. Okay. Finally, I'd like to show you the improvement of the mechanical properties of polycaprolactone with polytexan. And here we add the small amount of polytexan. You can see the mechanical property is improved like the polylactic acid. So at the same time, in this case, the biodegradability is also improved, is enhanced by the small addition of polytexan like this. So the polytexan can improve the mechanical properties and biodegradability at the same time, like two-way materials. You can see. Okay. I'd like to summarize my talk. We invented the sliding materials with movable cross-links by the cross-linking polytexan using cyclodextrin. The low coverage ratio polytexan yields the self-reinforcing sliding gels, tough gels, by the scratch-induced crystallization. We realize the compatibility between the toughness and the instant recoverability at the same time. And sliding material can improve the mechanical properties, fracture energy, and the small amount of polytexan addition improve the mechanical properties such as various polymeric materials, such as the PMMA resins. And also the small amount of polytexan addition improves the toughness and accelerate the marine biodegradability of polycaprolactone and polylactic acid. In the Moonshot project, Bridgestone and Cray have developed tough rubber and marine biodegradable fishing line, respectively, by strong collaboration with some academics. Thank you for your attention.
Thank you, Prof. Ito Koso. What an informative, interesting presentation from Ito Koso, especially when we see Prime Minister of Japan, Shinzo Abe, try to break the polymer. Okay, ladies and gentlemen, now we've come to the third speaker, Associate Professor Ferry G, PhD. He is the Associate Professor in Supply Chain and Logistic Management in the School of Business and Law of Edith Cowan University. He is currently a secretary to the Chartered Institute Logistics and Transport, Western Australia Committee. He is also part of the Supply Chain and Logistics Association of Australia. He has maintained a high quality of research throughout his academic career, including international scholarship leadership in the area of supply chain management and logistics, including regularly being invited to be a keynote speaker and to give public lectures at symposiums and international conferences in Indonesia, Malaysia, Vietnam, China, UK, and Australia. From 2017 until now, he already published more than 55 referred journal articles, including 31 articles in Q1 rank in the SIMACU. Furthermore, Dr. G has received research grants and awards adding up to over 185 million between 2010 until 2022. So, ladies and gentlemen, please welcome Associate Professor Ferry G, PhD. Associate Professor Ferry G, the time is yours.
All right, thank you very much. First of all, thank you for the International Conference Committee and also Indonesia to invite me for keynote speaker for the speaker for this session. I would like to present for today's session is Supply Chain Society 5.0 in the Australian mining industry. So Society 5.0, which is an extension of the Industry 4.0. So I would like to explain a lot more details about that. So in terms of my details, this is my email address and my WhatsApp number. So if you want to reach me for research collaboration in the area of industrial engineering, supply chain management, transportation management, and sustainability in transport and in operation management, and you'll be able to contact me. So this is about my details. I don't want to explain again as the moderator has introduced me. Now, this is the research project. So in the past 2-3 years, the first project I'm currently doing it now is developing a digital competency framework for the Australia energy industry. So currently I'm collecting data at this moment with the Australia energy industry. It's funded by Origin and Asset Institute in Australia. And the second project is a post-COVID-19 project. This project is already completed and is already published in the Q1 journal, which is the business continuity and resilience, capacity building and upskilling post-COVID-19. And the third project is about managing transport system investment risks, which is enhancing patronage prediction and adapting strategic asset management and appraisal processes to account for emerging trends and uncertainty. So this project already completed 3 years ago. So this project is, also has been republished in the top tier journal. The fourth project is about blockchain, optimizing regional SME resilience, employment workflow by customer-led do-it-yourself re-engineering of financing, planning and advisory services supply chain. And the fifth project is funded by City of Joondalup about waste and sustainability city. And the last two, what I just mentioned, is the large grants funded by federal government about smart city project. Now, I just want to give you more details about the mining industry in Australia. So mining industry in Australia is contributing a lot in terms of gross domestic product or GDP economy. So I'm located in Western Australia from, it's not really far from Jakarta. It's about like 4 hours by aeroplane from Jakarta to Perth, or from Bali to Perth, maybe 3 hours, 25 minutes. So Western Australia is a significant hub for the mining industry in Australia. So I'll just give you the major commodities for mining. Is the first one is iron ore. So Western Australia is one of the world's largest producers of iron ore with a major mining operation in Pilbara region. And the second one is gold, and WA is a major global producer of gold with extensive mining operation across the state. And the third one is lithium, and rare earth minerals. The state also has significant deposit of lithium. You know, in automotive, they introduce, you know, what we call decarbonization vehicle, which is they're not using petrol or different kind of diesel. They use what they call electric vehicle. They use lithium, one of the element using lithium for the autonomous, connected autonomous vehicle or electric vehicle. And the fourth one is the nickel. Western Australia has some of the world's largest nickel reserve with mines region like the Goldfield and the Pilbara. Now, the mining region in WA, if you look at here, we got Pilbara, Goldfield, Midwest, Gascoyne, Southwest, etc. Okay. Okay, so I think everybody knows what is Industry 4.0 as the topic of this international conference. So I'm just want to presenting, just give me 1 minute to explain the industry evolution. So if you look at 1850, the first industry evolution, starting the craft production job shop, you know, the steam-based machines, and that in 1910 is about 50 or 60 years later, there's a second industrial revolution that introduced electrical energy-based mass production, right? There's the first factory there in early 1910. And then for dedicated manufacturing system, the agile and lean manufacturing mass production, that is in that between 1910 1980. So we have Toyota production system. In Japanese philosophy, the third industrial revolution, late 20th century, and introducing CIM, which is computer integrated manufacturing, that's computer integrated based knowledge. Now, and then that is mass customization, flexible manufacturing system, and in between the third industrial revolution and fourth industrial revolution, they introduced the artificial intelligence, information technology, the big data, IoT, cloud, etc. Right? And then, you know, just before 2010, smart manufacturing system, cloud computing, CPM, which is cyber physical manufacturing, the fourth industrial revolution, that's a topic now, Industry 4.0. You know that what is, you know, it's about 13 years old, that Industry 4.0. It was born in early 2010. So that is, for example, IoT, cyber physical systems, digital platform, product service systems, network, etc. Now we are in the fifth industrial revolution. So most of you know that we are in the Society 5.0. So the adaptive connected manufacturing system, it is more towards mass customization cooperation between man, which is human, and machine, right? So that's why we have the human interaction. So not only for AI or machine learning, but we also have human interaction in there. So that is fifth industrial revolution. So, and also Industry Revolution 5.0 here introduces sustainable system, human-centric system, resilient system since after COVID-19 in 2023. And now we have what we call the sustainable system, human-centric, right? So this we call the human interaction with AI, machine learning, deep learning, and that is introducing the decarbonization, net zero initiative, low carbon emission, and all those things, the technology is there already, IoT, cyber security, etc. So where the human there? The human interaction there in 2020, late 2022, that Industry 5.0, which is Society 5.0. Now, Society 5.0 is a concept originating in Japan. envisioning a highly connected technology-driven society that integrate a physical and digital world seamlessly. In this stage, supply chain are expected to be even more advanced with a focus on sustainability, circular economy principle, and human-centric design. Now, can I just share with you my video presentation about the autonomous in a mining sector? So hopefully everybody can hear. It's about 2 minutes video presentation, right? So everybody just have a look.
The new digital era for industrial organizations is here, and for the mining industry, it is no different. Today's volatile commodity prices, evolving environmental regulations, and declining investment ability mean miners must shift their focus towards operational efficiency to stay ahead of the curve. Safety, social license to operate, and sustainable practices remain at the forefront of all operations. Employee safety and well-being must come first, as well as that of local communities and stakeholders, and the well-being of the very earth in which we dig. So how can a mine be sustainable, keep its workers safe, and maintain the respect and care for all stakeholders? The answer lies in digital transformation, applying digital tools and principles that enable mining companies to make the most of their efforts, to process information and make the best business decisions possible for everyone. Many organizations are attempting to analyze, manage and unify their data, processes and supply chains. The challenge many mining, metals and minerals companies now face is understanding how to bring these principles together in a systematic, comprehensive and intelligent way that will truly transform their operations. As with other industries, it's essential to operate with the highest levels of efficiency, corporate social responsibility, and regulatory compliance. When applied successfully, a digital transformation strategy can accelerate your mining operations, enhance your productivity, reduce your costs, and help you surpass your competition. Digital transformation is helping mining companies globally save more than $500,000 in unplanned downtime, increase workforce efficiency by 20%, and improve data accuracy by 10 to 20%. But what does it take to implement a successful digital strategy? And where do you focus your efforts to get the greatest returns? First, start with enhancing edge-to-enterprise visibility and control. Then look at how you can optimize your value chain and to understanding the health of your assets. Leading companies have achieved 10% increased production by improving overall equipment effectiveness, 15% reduced cost in maintenance, and 80% reduced safety incidents. Aviva is helping leading companies to drive efficiencies throughout the mining lifecycle. Let us lead you on your digital mining transformation to shape your digital sustainable future.
Okay, so let's just go back to my slide. So if you look at that video, just, less than 2 minutes, the video talking about the mining operation, talking about the automation, talking about sustainability. So now I just want to explain the supply chain. Since my PhD was from the University of Sydney, I graduated at the University of Sydney. My PhD was in supply chain management. So I just want to explain, most of you in this room, maybe you don't know what supply chain, the evolution of supply chain. Now, supply chain was born in early 1990s. So pretty much is about, now it's 2023, right? So you can see, right, how many years for that. It's about nearly, you can calculate nearly 30 more years for that, okay? So if you look at activity fragmentation to 1960, right? And then in 1960, all the activities of function is all fragmented. So we have a demand forecasting, a purchasing, warehouse, material handling, packaging, production, information system, marketing, etc. Now, early 1980s, So all those function and operation become into one we call purchasing and material management. And then the second division is a physical distribution, right? So, and then in late 1980s is integrated logistics. So integrated logistics. So you can see, right? So early 1990s, so supply chain management was born, okay? If you look at supply chain, that's the management, that's the philosophy of activities, you know, to facilitate the fulfillment of customer order for a manufactured goods. There's several operational function activities. For example, you have the suppliers, they provide raw materials, components, spare part to the manufacturing companies or to the factory, to the production companies, for example. Then for production companies, you have warehouse, you have storage, you have distribution centers building, for example, and you have truck and you have transportation equipment. Then you have, you know, final consumers and you have retail store. That all end-to-end supply chain. First thing, we need to work very closely with suppliers. Second, we also have purchasing and procurement activities. Then we purchasing, transportation, which means from one place to the final destination, for example. Then we also control the inventory, demand forecasting, managing risks and uncertainties that may disrupt the supply chain. Supply chain, you can also measure that supply chain business performance, right? Reduce costs, for example, improve efficiency, improve quality, and then we also ensure that sustainability. So my presentation is about supply chain society 5.0, refer to the integration of digital technologies. Yes, artificial intelligence, advanced analytics in supply chain management. It aims to create a highly efficient, sustainable, and interconnected supply chain ecosystem, right? So that is Supply Chain Society 5. So I'm sure so many people in this room, if you want to do research, I can tell you, supply chain, industrial engineering is a multidiscipline. You'll be able to bring it back, the technology advancement, cutting edge technology, AI, deep learning, drone technology, IoT, cloud-based, etc., into the supply chain operation. Human-centric design, that is a good as a research in the next, from now up to the next 5-10 years. If you want to do PhD, if you want to do research, the Supply Chain Society 5.0 as a very good research up to in the next 10 years. So supply chain in the mining, I just want to show it to you what supply chain structure in the copper mining. So we look at raw material, which is in, you know, you got external supplier, you got bulk fuel, and you got mining site, which is stockpile copper or copper concentrate, you know, cathodes, for example. And then you have rail, right? And truck, for example. And from mine, you got external supplier, copper concentrate, and you got smelters, which is cast houses. And then in between, you got refineries, and you got external suppliers, which is, you know, lime, copper concentrate, or caustics, for example. And then you also can see the mining operation. You can see on the top there, raw material inventory levels, melting, rolling operation, and inventory, then refining operation. And then you got port, because we need to export, right? For example, from Tanjung Priok or Tanjung Perak, for example, from Indonesia. You also can export, you know, all the, you know, steel, anything for mining product, for example, to other countries, right? And then you got domestic customers, you got international customers. Then this is, we talk about international supply chain. So what is the future research in Supply Chain Society 5? Research in the mining sector, since I'm doing research now in the mining sector, within the context of Society 5.0 is likely to focus on several key areas to address challenges, leverage opportunity for sustainable, efficient, and responsible resource extraction. The first one, everyone knows what the digital twin. Digital twins for E2E, which is end-to-end, right? Supply chain feasibility. So digital twin for end-to-end supply chain feasibility. So developing and implementing digital twin technology to, what is the purpose digital twin? To create virtual replica of mine mining in operation. This allows for real-time to monitor, simulation, optimization of processes, leading to increased productivity and reduced environmental impact. So creating digital twin for mining operations involve a multi-step processes, different steps, such as, of course, we need to collect the data. There are two types of data, primary data. Then you integrate, then you model your data, data visualization. Now, I just want to give you the methodology for digital twin for mining. So we need to define the objective and scope, right? So clearly define the objective of creating the digital twin. This could include improving operational efficiency, optimizing resource extraction, ensuring safety, minimizing environmental impact. So then the next stage, after you scope and determine the objective, we need to, start the data collection. What kind of data, in the mining sector, in Australian mining industry? So gather data from various sources. These can include geological data, information about the composition, the structure, and quality of the mineral deposits, for example, equipment, and could be sensors in location, the performance and condition for all the equipment data, environment, including temperature, weather, water condition, humidity, air quality, etc. Operational could be production rate and the material flow, resource utilization, including safety for people in the workplace. Information on incidents, the near misses, the safety protocol, etc. And geospatial data, including maps, right? GIS, Geographical Information Systems. Everybody knows that GIS. Everybody knows satellite images and other location-based information. So the next are data integration and processing. So the integrate and collect the data into the centralized platform or database. And this process, we also need to clean, format, and normalizing data to ensure data is reliable, accuracy, consistency, valid the data, then come to the model and simulation. Everybody, you are in this room, mostly you are quantitative and mathematical modeling. You know what the stochastic simulation, you know what the heuristic simulation. Now, developing mathematical computation model to represent the physical processes and system within the mining operation. So we also have real-time data streaming, implement system for real-time, data streaming and processing. What is it for? Is it to allow that continuous update monitoring of digital twins, enabling timely decision making? So what happened? All the business people really need to have all the supply chain or computer science or information technology engineering scholar tell us after that simulation, tell us what the scenario, tell us this is based on for the decision making, right? Then we also need to look at digital twin for the visualization user interface. Design user interface in to visualize the digital twin, could be 3D printings, AR, augmented reality or virtual reality may also be used to immersive experiences for visualization. Now, the next project you research, you may think about, consider about how we integrate the Internet of Things, sensor, right? IoT for real-time monitoring. So I think when you look at in the last 3 years, so many papers now, so, with the integration with IoT and sensor IoT, right? IoT is Internet of Things, right? The connecting IoT devices sensor to help to the digital twin platform to enable real-time data collection and feedback. So we need to have IoT, I can tell you. So we need to have sensor. So we need to have radio frequency identification still, right? And the machine learning, AI, deep learning, and predictive analytics. So implementation of machine algorithm to analyze historical real-time data. So what is it for? Of course, we need to predict future trends, optimization processes, and providing actionable insights. Of course, as an industrial engineering scholar, as a mechanical engineering scholar, what continuous improvement has been introduced in the digital twin for end-to-end supply chain visibility. The feedback loop and continuous improvement, this is a good for operational adjustment, the continuous improvement cycle, how we improve, right, that the mining operation itself in terms of the efficiency or effectiveness. And last, for that particular research, you also can consider about security and data integrity or data privacy. So that is coming for the cybersecurity. Implement robust security measure to protect sensitivity data. Maybe to comply with the data privacy regulation, right? It's a very important research. Training and adoption, if you are in engineering management scholar or in a management of technology, this is maybe you work with this business school, how we provide the training to the people on how to interpret the digital twin. Look, because digital twin is not the name of game, right? You have to train people, right? So that's something you need to encourage adoption, integration into daily operational practices. And of course, you need to monitor and maintenance, not only continuous improvement. Well, when you do continuous improvement, you need to monitor and do maintenance, right? Regularly. Human capital is very important. Not only training adoption, you also investigate the skill set. That is one of my project with the Australia energy sector to measure the digital competencies, to investigate the skill sets, training needed for a workforce in a highly digitized, technological advanced mining sector, ensuring that personnel can effectively leverage these technologies. So by following this methodology, mining operation can create a powerful digital representation of their processes, enabling better decision making. So first is decision making, ladies and gentlemen. So that's something that's very important. Resource utilization needs to be optimized. And of course, the final goal to improve efficiency, supply chain efficiency, and supply chain sustainability. Are we ready to promote a net zero emission, zero carbon? So do you think is that easy? No, it's not easy, right? So that is, we're still working hard to achieve that goal for the net zero initiative, right? So The last, I just want to share the ESG. ESG is environmental, social, and governance. I'm not quite sure in this room you're interested, but anyway, that is ESG in the supply chain. So ESG is environmental, social, and governance, right? And how can they do this? Net zero, I think mentioned before. Circular, driving resource efficient business model and ecosystem. Trust by mitigating negative environment and society impact. Okay. So due to the time, I'm not able to share the video presentation. I'm so sorry. And then as a moderator has introduced me, I published a lot of papers, and this is the reference list. And a lot of papers, I collaborated with so many Indonesian scholars, right? And then with UGM, with Undip, with Pajajaran University, with UI, you know, and so many papers we produce, and also with Vietnam, with Thailand, with my doctorate student, my PhD student, my the other postdoc student somewhere in United Kingdom, in United States, in California, you know, at Berkeley campus, UCLA, and then some papers we work together, we publish, and we working hard to publish in the top tier journal. So we also want to promote for this conference, please engage to learn to the transfer knowledge and research experience for the PhD scholars and the two research scholars in this. It's amazing conference. We have more than 300 participants. It's amazing conference. So once again, thank you for listening, ladies and gentlemen. And I'm more than happy to take any comments and feedback and questions. And again, all the best to you all. Thank you.
Thank you, Prof. Ferry. So now, ladies and gentlemen, we've come to the question and answer session. I'd like to have maybe the question from the participants, please. Okay, we've get some question from several participants. Like to have maybe the question from the participants, please. So this is the first question is from Mr. Fandi. Okay, get some he has question from several Mr. participants. Digital transformation will lead to the improvement of efficiency. Maybe the question from the participants, please. This will also impact the first or question is from Mr. Fandi. Some question from several participants. Digital transformation will lead to improvement of maybe the question from the participants, please. This will also impact the first or question is from Mr. Fandi. Some question from several participants. Digital transformation will lead to improvement of maybe the question from the participants, please. This will also impact the first or question is from Mr.
Good morning, Doc Inda. Good morning.
Good morning, Mr. Willy.
Okay, good morning. So, what a very fruitful discussion coming from different speakers. For that particular question, before we come up or before we embrace that particular, for example, those available technologies right now in the country, for example, or in Indonesia, we need to study first. We need to do a crucial study with regards to the present number or with regards to our human resource availability, so that since we're going to adapt, let's say, with the recent technology, also we will consider not to have a negative effect in terms of our available human resource. So that's why, based on my discussion, based on my previous discussion, of course, we need to consider the empathy, considering that it will not, for example, suffer the productivity as well as the quality. We need also to consider what will happen to our human. Of course, we need to have a crucial study, of course, a lot of planning before we come up or before we embrace that particular available technology in the market. Thank you.
Okay, thank you, Mr. Billy. The next question, please. Okay, the next question I believe is for Prof. Ito Kozo. It is from Bu Laili. What is the major compound of the non-food biomass that we can use to formulate the multi-log biopolymers? And why the biopolymers is called as multi-log? Prof. Ito, you've mentioned before that your research mainly focus in the formulation of some types of multi-log biopolymers. So Bu Leli want to know what is the major compound from the non-food biomass that we can use to formulate that compound. Is Prof. Ito Kohyo is still joining us in the seminar? Okay, maybe there is something else that Prof. Ito has to do, so I can send the question through email through Prof. Ito Kohyo, and hopefully when Prof. Ito reply, I will inform the answer to Bu Laili, and maybe several others question that is mentioned for Prof. Ito. Okay, this is Bu Farika also asked for Prof. Ito. Prof. Ito earlier mentioned that the polyrotaxan is based on cyclodextrins. Is there any other raw materials for the synthesis of polyrotaxans? Because I believe polyrotaxan is a tremendous material. Prof. Ito earlier mentioned that the addition of small amount of polyrotaxan can enhance the durability as well as the biodegradability of the materials. So maybe we can move to the next question. Maybe we can search question for Prof. Feriji. Okay, this is from Abdullah Afnil. The question is, as we know, Indonesia has very abundant resources. So what technology that we can use that resources in Indonesia can be processed properly? Thank you. Prof. Ferry, this is for you, Prof.
Thank you very much. Very good questions indeed. And it's good for research project. So, look, with the supply chain industry 4.0 or supply chain industry 5.0, several research can be done in Indonesia, particular mineral resource industry, right? One of the technology you can use is what we call digital twins. What I just presented, the methodology, digital twins for supply chain feasibility, for end-to-end supply chain feasibility. So first thing, before you determine and apply the technology, you really need to understand the business and the industry structure, the product, as well as the challenge or maybe problems there. And then you can think about the methodology, right? And the second technology you can use, of course, we talk about drone technology. So drone technology, if you look at research, in the subsea, for example, we cannot use, certain for example, like how many, maybe more than 1 kilometers, under the water is a subsea. So we can use the drone. We can use the drone technology for capturing the data for underground, maybe 1 kilometers underground, to see what's happening there. So we can simply use the human or people there because it's a high risk, right? And that drone technology can use the sensor, to capture the data, and then the data can be shared to geologists. Geologists, they can see, and then they can tell us for the next step for the decision making, right? Now, the third actually technology you also can introduce, with the cloud-based technology, with the Internet of Things, of course, everything of the Internet, right? IoT integration and sensor, that I mentioned before, implementing in drone, and then technology for decarbonization, because we want to promote a zero emission or zero carbon. Now, so many technology, we talk about the electric vehicle, autonomous vehicle, and autonomous vehicle is a driverless, right? In some countries like Berlin in Germany, US, including in Australia, they introduced what we call autonomous vehicle, right? An electric vehicle, for example. We're not using fuel, maybe we use different kind of like hydrogen, right? It's alternative fuel, right? And then the next technology, you also can think about what we call analytics of big data, right? So analytics of big data gives so many software and can help, to deal with the big data, right? So this is what we call supply chain analytics, right? So if you look at many papers already published in the last 2-3 years in relation to mineral or resource sector, and please take time to read. This is the thing, if you want to do research, write a thesis, write a dissertation, you need to get very good quality journal for you to read, for you to understand, for you to do research, right? So that's why we need to produce high quality papers from Indonesia, from ASEAN country scholars, right? Don't submit the paper to the predatory journal. Predatory journal is a very dangerous, especially, can damage university or scholar reputation, right? Okay, so I think that's my answer. Hopefully I can answer the question. So if not, then just send me WhatsApp or email. Maybe I'm more than happy to explain a little bit more.
Okay, thank you, Prof. Feriji. It seems that there is one more question for Prof. Ferry.
Yes, just ask more questions. I'm more than happy. We got a lot of time if you want to.
This question came from Mr. Subhan. Pak Subhan, would you explain how AI can improve the safety of the mining process, especially in underground mining?
Okay. This is another research questions as well. So this is implementation of artificial intelligence machine learning. The artificial intelligence machine learning is still very new research, in particular for underground or underwater. Underwater is not yet, right? So underground, the artificial intelligence, this is we talk about not only safety, but also the security. So think about it. Artificial intelligence without embedded with the cyber security is going to be collapse your machine learning. Why? You have to think about it, safety and security in terms of the information. The machine learning is machine. AI is the technology itself. But everything you have to think about information security embedded with the AI. And this is the question about how. We talk about the methodology. The machine learning That is something we talk, the artificial intelligence that's more focused. The three pillars you have to understand, that is AI, artificial intelligence. So everybody knows with the ChatGPT, Chat AI, and all those things, even I just ask my PhD or my students, don't do anything assessment, use a ChatGPT, because otherwise you cannot attend the graduation ceremony. I only can give the certificate to the machine, right? Which is the ChatGPT, isn't it? So that is, you need to think about the AI for mining sector. Is a very good in terms of the methodology. Look, the safety itself, you have to look at what data available. You mentioned about this safety and in security a mechanism. So the data, are you looking at in terms of the data from underground, for example, capturing data for geologists? Sorry, because I'm not in geologist, right? So it's a geologist in Indonesia, I'm sure you got so many faculty of technology industry, and under faculty of technology industry in Indonesia, you got teknologi perminyakan, isn't it? And whatever you call in Bahasa Indonesia. And then you got Fakultas Teknologi industry, and you can see. And then what kind of geologist data wants that? And then once we have better understanding what they want, you really need to set for this particular methodology for AI to ensure all the data capturing from the AI actually really relevant for geologists, really relevant for supply chain, really relevant for business people, really relevant for scientists or environmental people. Why environmental? Look, because every time we talk about pollution, everything we talk dealing with the climate change, everything we dealing with the climate or weather condition. So for example, in Queensland, they got problem with bushfire, what we call bahasa Indonesia kebakaran hutan. That is Queensland, they got problem because the weather, and then it's a bushfire, right? And it destroy many houses, and it destroy so many woods and forests, right? That is, we need to think about it, about the climate change and environmental. And now, in the last 2 years, so many research can be done, implementation of AI for environmental impact, right? Environmental impact. And plus, in a supply chain and transportation logistics. So I'm not coming from computer science people. So I need to work together with computer scientists, computer science scholar, and I'm a supply chain expert, right? I need to work with geologists. Look, because, for this, you can't work by yourself, because what happens, you really need to rely on the scholar expertise, right? And this is something we need to start with the supply chain collaboration, what the conversation start with, and what we want to do in terms of that research. So very, very good question. So I really want to see that research question can be done in particular, maybe thesis for 3 years project, right? Because this question is a very specific, right? In terms of AI, safety, and for the mining operation is underground. Well done. Congratulations. Any more questions? Sorry, I don't want to be like dominant.
There is two questions for all the keynote speaker. For Mr. Willy, this is from Stefani and Andri Wijaya. How about challenge? What are the main impact of the Industrial Revolution 4.0 on the universities? Maybe Mr. Willy C. Puketin can answer this.
Good morning. So when it comes to the impact of the Revolutionary 4.0, basically there are similarities between the manufacturing and also in the university. Of course, in the manufacturing, if we are going to target the impact of that particular 4.0, so of course we need to focus more on particularly in terms of the productivity or the efficiency. The same in the university, for example, so we integrate those available technologies because we want to have a better efficiency of or the productivity for our manpower inside that particular university. And also, the same in the manufacturing, for example, between manufacturing and then the university. So we need to automate those repetitive tasks. Those tasks that not add value, or for example, we're going to eliminate that, those tasks or activities that does not add value to that particular process. And also, we streamline the operation. And the bottom line, for example, at the end of the particular implementation, between manufacturing and the university, we need to implement the ease of doing things right and at the same time. So in terms of the productivity and efficiency of our manpower. And of course, the impact, it's more on the improvement to the major stakeholder in the university, which is our student. Okay, thank you.
Thank you, Mr. Willy. So we've got the last question maybe for all the keynote. How about challenges security of society industry 5.0, and what is the problem of many technology to collaborate in society industry 5.0? Thank you. It is from Andri Wijaya.
Okay, so very good question. Yes, so this is very specific about challenges and concern in Industry 4.0, Industry 5.0. Look, the challenges, I can tell you, now technology is growing very fast, right? This is the challenge for university, not only Indonesia, not only in Philippines, not only in Australia. We produce the graduates. Are we updating the curriculum, for example? What I can see, so many, programs, so many, department, when they finish the degree, look, I really sometimes feel, so sad when the students apply the job and they cannot just answer the question when they got the shortlist interview. So the first challenge of what I can see is, are we ready from university point of view, from the student as a graduate when they get a job there, as a technology, as an industry or as a business. Because look, so many business like small, medium enterprises, they still use the traditional approach. They still use a paper base. When the taking order, use a paper base, and you can see, are we ready? Is a technology readiness. That's the first challenge. And second challenge is with the people behavior itself. Now, unfortunately, in the last 3 years, when the COVID hit more than 222 countries around the world, and all you can see impacting on the COVID-19, so many business owners, whatever, people, so many people, mental illness. I can tell you mental illness in Australia or maybe around the world, increasing by 12.2% because of that particular pandemic. So the behavior, that particular safety, the well-being, right? People and the workforce is very important. Number 3, now the challenge, I believe, right? When we talk about now everything technology, everything about robot. So what about people then, right? And especially like India and Indonesia, for example, more than how many population, right? So we still rely on labor. So I'm not like fans into the technology, unfortunately. I'm still really need to use, even though I finished marking, I'm still using, to be honest, not using like iPad, to do online marking, but I've still used some particular context, use the paper base to give a comment using my handwriting, right? So with the people itself, so make sure the skill set, the competencies, capabilities, right, must be the same with the chat GPT or chat AI, unfortunately. So you can see when you search in the chat GPT, chat AI, they're fasting so fast. And then even as a human, we cannot fast so fast as compared to the chat GPT or chat AI. So unfortunately, why that technology is just more capable than the human? It is not right. Should be the other way around, right? So we should control and, guide that technology, not the other way around, right? So that's something, my opinion. Maybe the other two speakers would like to add.
Thank you, Prof. Feriji. Prof. Willy C. Bukredin, the time is yours to answer the latest question. How about challenges, security of society industry 5.0? And what is the problem of many technology to collaborate in society industry 5.0?
I think one of the major challenge, similar to what Sir Ferry mentioned, it's the according to Sir Ferry, it's more on the behavior, and also plus the readiness of the available human resource. Another one, it's more on the budget, the capital itself, so that we can compete to other companies. Let's say if we're going to have the competition, of course, one of the factor is the budget, so that we can embrace to the latest technology. And then since we focus more on the human-centric in terms of the society 5.0, so of course we need to train our human resource. We need to equip them when it comes to that particular available skills plus the knowledge, so that from the 4.0, the technology, the integration of different technologies. So if we're going to embrace that to society 5.0, so it will parang similar to the particular implementation. So it will run smoothly, and then we can execute everything perfectly. And then of course we need to sustain, and also we can sustain what we are going to target or to improve, or what is written to our objectives pertaining to the society 5.0. Thank you.
Thank you. Prof. Ferry and Prof. Willy, it seems that all of the participants are captivated by your presentation. So we got still more question from the participant. This is from Atta Gantari. How can Indonesian manufacturing companies ensure a smooth transition into Industry 4.0 without disrupting their operations? Maybe Prof. Ferry first can answer this question.
Yes, so the Indonesia manufacturing, what I can just say that this is, we talk about technology disruption, right? The transition itself, actually, it should be no problem. So the question is how, meaning that the industry manufacturing to see that what the existing technology, I'm sure the Indonesia manufacturing, maybe the large manufacturing company like KIA, or maybe Honda, or maybe Toyota, or I do not know, right? So maybe they use a robotic technology. They use maybe, advanced a sensor, or maybe radio frequency identification, to tracking all the spare part and component, all the inventory, etc. So the transition, what I just said, that in terms of this disruption, this is what I can say, the supply chain disruption, it should not be problem. The only thing you have to, second pillar, a second consideration after you understand the existing technology, number two is you really need to see what is your production, or, this is we talk about manufacturing goals in your industry. Because with the Indonesia manufacturing goals, if you want to implement lean manufacturing or agility, then when the transition, all these into the technology want to be adopted, want to be implemented, right? The transition can be done, run smoothly. Well, you have to think about it within 12 months, within 18 months, or 24 months, whether or not that lean manufacturing technology or agility supply chain technology can be implemented, such as, right, using the transportation management system or warehousing management system or order management system or logistic information system, for example. So those four pillars, this is something we can say that transition runs smoothly for the, without any disruption of the supply chain. This is very important. We need to understand. The only problem when you invest something and the production process is going to be problem. And maybe the workers, you got very good technology in your business, in your factory, and your worker, I do not know how to do it. I do not know where is the start button. You know what I mean? And then they don't know start button, right? So this is very important, because that's one of disruption. And that's one of the, maybe what we call the challenge of the concern, right? So of course, when you buy something, invest something, you have to think about it because it's not like 1,000 rupees, right? Even 1 million rupees. Many businesses, factories, or even university, when you invest lab, it's not easy. Do you have any capacity, like people working in the lab? They capable enough or not? Is that something relevant with your curriculum? Is that relevant with industry ready? Because when you build up the lab, well, that's something like 20 years ago, right? And it just wastes too much money for university. You with me? So that's the example. Sorry, I'm talking too much now. Maybe Prof. Willy can answer that questions.
Prof. Willy, please.
Okay, Doc Inda. So actually, it is very evident that for every changes, there are resistance to change. Okay? And then, so the convergence of the 4.0 to society 5.0, of course, it will reflect more on a broader shift towards a more holistic and sustainable, of course, the human-centered approach. So if everything has been planned, if everything has been discussed and communicated to all members of that particular organization, so the values of the society 5.0, which is the human-centric, so we can look forward to a future that, for example, that particular innovation is not just only efficient, but also will deeply attune to the needs and well-being not only of a certain individual, but as a society as a whole when it comes to the particular improvement or the benefits that we're going to attain. Thank you, Doc Indan.
Thank you. Ladies and gentlemen, now finally come to the end of the seminar. Before I close the seminar, I would like to take the conclusion from what the speaker has presented. I believe that efficiency and productivity enhancement, circular and sustainability are the major keywords for our today's meeting. I'd like to thank the speaker for the informative and interesting presentation, and all of the participants for the very active participation. Finally, give the applause for the speaker for all you all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. All the best to you all.
Thank you, Prof. Ferry. Thank you, Prof. Willy. See you soon in another occasion. Hopefully.
Yes.
Hopefully we visit you in Indonesia.
Prof. Ferry,
We will
you are
hope
also
your
invited in the
attendance,
Philippines.
Prof. Ferry
Yeah,
and Prof. Willy. Thank you.
Hopefully I visit in Manila, Philippines.
Sure. Is it tomorrow?
Next month, Prof. Willy.
Yeah.
Okay. perlu kami sampaikan kepada seluruh peserta SNST maupun ICIMICE untuk breakout. Nanti kita akan mulai lagi jam masuk ke breakout. Oke, terima kasih.